Hi there, welcome to Ethio-Hahu tutorial class. And my name is Kikacho, and I'm going to do a problem related to kinematics of particles. Specifically, today I'm going to do this exercise. The exercise says a particle starts from rest and accelerates as shown below. The particle's acceleration versus time graph curve is given like this: acceleration in meters per second square and time in second. Between t is equal to 0 and t is equal to 10 seconds, the particle has a constant acceleration of 2 meters per second. Between 10 seconds and 15 seconds, the particle has zero acceleration. And between 15 and 20 seconds, the particle has an acceleration of minus 3 meters per second square. Therefore, we need to find the particle's speed at t is equal to 10 seconds and at t is equal to 20 seconds, and the total distance traveled by the particle in 20-second interval. To do this, let's classify the three parts. The first part is accelerated motion, the second part is constant motion, and the third part is decelerated motion. Therefore, this one is accelerated motion, accelerated motion. This one is constant motion, and this one is decelerated motion. Therefore, first let's consider the first part, accelerator part. In the accelerator part, this is between t is equal to 0 and t is equal to 20 seconds, 10 seconds, sorry. In this part, the particle has acceleration of 2 meters per second square. That means to find the speed at 10 seconds, let's say time axis, time in second, and velocity in meter per second. Acceleration is equal to 2 meters per second square means the particle increases its speed 2 meters per second every second. Acceleration is equal to 2 meters per second square means the particle increases its speed 2 meters per second every second. Therefore, at t is equal to 0, the particle velocity is 0 because the particle starts from rest. After 1 second, the particle increases its speed by 2 meters per second. Therefore, when t is equal to 1 second, the particle's velocity is 2. When t is equal to 2 seconds, the particle's velocity is 4, 3, 6, 4, 8, 5, 10, 6, 12, 7, 14, 8, 16, 9, 18, and 10, 20. The particle's velocity at t is equal to 10 seconds is 20 meters per second. Therefore, the particle's velocity at t is equal to 10 seconds is equal to 20 meters per second. This is one option. The other option from the graphical representations of uniformly accelerated motion. Here we have given acceleration versus time graph curve. The area under acceleration versus time graph curve is always changing velocity from graphical representation of uniformly accelerated motion. The area enclosed by acceleration versus time graph curve, and the time axis is always equal to change in velocity. That means the area under this graph, this area, that's A1. Area A1 is equal to base times height. Area A1 is equal to base times height. In this case, our base is 10 seconds and our height is 2 meters per second square. This is equal to 10 seconds times 2 meters per second square. 1 second goes with 1 second. Second goes with second, 1 second, and 10 times 20, 2, 10 times 2, 20 meters per second. This is the area under this curve. But from equations of motion, from the definition of acceleration is equal to the time rate of change of velocity. Acceleration is defined by the time rate of change of velocity. This is equal to final velocity minus initial velocity divided by time. V final minus V initial divided by time. Since the initial velocity is 0, since the particle starts from rest, V naught is 0. Since V naught is equal to 0, acceleration is equal to V final over T. And from this, V final is equal to A times T. A times T is the area under this curve, because if we have acceleration axis and time axis, the area under this curve, this rectangle, the area under this curve is area is equal to base times height. Our base is time axis and our height is acceleration axis. Therefore, A times T is the area under this curve. And from this equation and this equation, V final is equal to A times T. A times T is area 1. That's equal to A times T. A1 is 20 meters per second, because A times T is the area under this curve, and that area is equal to 20 meters per second. Is equal to 20 meters per second. The next part is constant motion part. This is between t is equal to 10 and t is equal to 15 seconds. For the constant motion part, the acceleration is 0. The acceleration is 0 because it's moving with constant velocity or speed. This implies V initial is equal to V final. This means V initial is velocity at t is equal to 10 seconds, and V final is velocity at t is equal to 20 seconds. Therefore, V at t is equal to 10 seconds is 20 meters per second. 20 meters per second. Therefore, V at t is equal to 20 seconds is equal to V at t is equal to 10 seconds, which is equal to 20 meters per second. Therefore, V is equal to 20 meters per second. This is constant between t is equal to 10 seconds and t is equal to 15 seconds. For the decelerated part, between t is equal to 15 and t is equal to 20 seconds. For this part, the deceleration is minus 3 meter per second. The deceleration is minus 3 meter per second square means the particle decreases its velocity or speed 3 meter per second every second. Therefore, this is our time axis and is velocity axis in meter per second. Our initial time is 15 seconds. When the time is 15 seconds, the speed is 20 meter per second, because at t is equal to 15 seconds, the speed is 20 meter per second, because the speed at t is equal to 10 seconds is equal to the speed at t is equal to not 20, 15. It's 15, sorry. The speed at 15. The constant motion is between 10 and 15 seconds. The speed at t is equal to 15 seconds is equal to the speed at t is equal to 10 seconds, which is equal to 20 meter per second. When t is equal to 15 seconds, the speed is 20 meter per second. When the time is 16 seconds, the speed decreases by 3 meter per second from 20 by 3. So that is 17, because a is equal to minus 3 meter per second square means the particle decreases its speed 3 meters per second every second from the initial speed. When t is equal to 17 seconds, the speed decreases by 3 from 17, that is 14. When t is equal to 18, the speed decreases to 11. When t is equal to 19, the speed decreases to 8. And when t is equal to 20, the speed decreases to 5 meters per second. Therefore, the speed at t is equal to 20 seconds is equal to 5 meters per second. On the other hand, from the area under this curve, let's A2. Let's calculate area A2. Area A2 is equal to base times height. Our base is 5 and our height is minus 3 meter per second square. This second, 1 second goes with 1 second. This is equal to minus 15 meter per second. But area under acceleration versus time graph curve and the time axis is always equal to the change in velocity. Change in velocity is equal to area of acceleration versus time graph curve and time axis. The area enclosed by acceleration versus time graph curve and the time axis is equal to change in velocity. That is v final minus v initial is equal to change in velocity is equal to the area of this acceleration versus time graph curve. This area is A2. This area A2 is minus 15. But B naught is B at t is equal to 15 and B final is equal to B at t is equal to 20. Therefore, B at t is equal to 20 is equal to B naught is moved to the right. B naught minus plus A2 is equal to B naught is 15. Velocity at t is equal to 15 seconds, which is equal to velocity at t is equal to 15 seconds is 20 plus A2 is minus 15 meter per second square minus 15. 20 plus negative 15 is equal to 5 meter per second. Therefore, velocity at t is equal to 20 seconds is equal to 5 meter per second. Since we have found the speed at t is equal to 10 seconds, at t is equal to 15 seconds, and at t is equal to 20 seconds, let's first draw velocity versus time graph curve for these three parts of motion. Velocity versus time graph. Velocity versus time graph curve of this motion. Time axis in second and velocity axis in meter per second. The first part from 0 second to 10 second, the particle has a constant acceleration of 2 meters per second square. Its speed increases 2 meters per second every second up to 10 seconds. Between t is equal to 10 seconds and t is equal to 15 seconds, the particle has a constant velocity of 20 meters per second, and between 15 and 20 seconds, the particle has a deceleration of minus 3 meters per second square. Therefore, for the first part, between t is equal to 0 second and t is equal to 10 seconds, the particle has a constant acceleration of 2 meters per second square. The speed increases linearly from 0 to 20 meters per second. This is 20 meters per second. At t is equal to 10 seconds, the speed is 20 meters per second. Between t is equal to 10 seconds and t is equal to 15 seconds, the speed is constant. This is a constant motion. And between 15 seconds and 20 seconds, the speed decreases 3 meters per second every second up to 5 seconds. The speed decreases linearly by 3 meters per second every second. This is for the first part, accelerated part, constant motion part, and decelerated part. To find the distance traveled between t is equal to 0 and t is equal to 20 seconds, we need to find the area under this curve. The area under this curve is always equal to displacement. Area enclosed by velocity versus time graph curve and the time axis. Is equal to distance, that is area is equal to distance traveled by the particle. Therefore, to find the area enclosed by this graph, this is velocity versus time graph curve, and this is the time axis. The area enclosed by this velocity versus time graph curve and the time axis is always equal to distance. To find this area, we need to separate into 3 parts, even into 4 parts. The first part is A1, this one. The second part is A2, this one, rectangle. And the third one is A3, this triangle part, and A4. This is the rectangle part. Therefore, area A1, let's find area A1. Area A1 is the area of this triangle. Area of triangle is half times base times height, half times our base is 10 seconds, our height is 20 meters per second. 10 seconds times 20 meters per second, because our base is 10 seconds and our height is 20 meters per second. This is equal to Second goes with second. By to 1, by to 5. 5 times 20, 100. 100 meter. Area A2. Area A2 is area of this rectangle with base 5 second and height 20 meter per second. Base times height. Our base is 5 seconds because between 10 and 15 seconds we have 5 seconds times height is 20 meter per second. Second goes with second. 5 times 20, 100 meter. Area 3. Area 3 is the area of this triangle. The area of this triangle is base 5 second and height from this to this 20, from this to this 5. 20 minus 5 is 15. Half times base times height is equal to half times our base is 5 second. Our height is 15 meter per second. Second goes with second. 5 times 15, 75, 75 by 2, 37.5. Area 4 is rectangle with base 5 second and height 5 meter per second. Base times height is equal to 5 second times 5 meter per second. Second goes with second. 5 times 5, 25 meter. Therefore, distance is equal to the sum of the area of each portion, A1 plus A2 plus A3 plus A4. A1 plus A2 plus A3 plus A4. A1 is 100 meter plus A2 is 100 meter plus A3 is 37.5 meter plus A4 is 25 meter. This is equal to 262.5 meter. This is the total distance traveled in 20-second interval. On the other hand, we can do this example using equations of motion. We can do these examples using equations of motion. How? Or from equations of motion. The first part, accelerated part. In this part, the initial velocity is 0. The acceleration is 2 meter per second square and the time is 10 seconds because in the first 10-second interval the particle accelerates. Therefore, we are going to find the speed at t is equal to 10 seconds. From this equation, from B final is equal to B initial plus A times t, B final is equal to B naught is 0 plus A is 2 meter per second square times t is 10 seconds. Second goes with 1 second. 2 times 20, 2 times 10, 20 meter per second. This is the speed at t is equal to 20 seconds. For the second part, constant motion part, the acceleration is 0. B final is equal to B initial. This implies B initial is B at t is equal to 10 seconds. That is equal to 20 meter per second. Therefore, V final is equal to V at t is equal to 15 seconds is equal to V naught, that is 20 meter per second. Third part, decelerated part. In this case, the acceleration is minus 3 meter per second square. Initial velocity is velocity at t is equal to 15 seconds, which is equal to 20 meter per second. We need to find B final, that is the speed at t is equal to 20 seconds. From this equation, B final is equal to B initial plus 80. B initial is 20 meters per second plus the acceleration is minus 3 meter per second square times the time interval between t is equal to 15 seconds and t is equal to 20 seconds is 5 seconds. Second goes with 1 second. This is equal to 20 minus 3 times 5, 15. 20 minus 15, which is equal to 5 meter per second. This is the speed at t is equal to 20 seconds. The next part, distance. How can we find distance traveled by the particle in the first 20-second interval? To find distance, let's use equations of motion. Using equations of motion, we separate the motion into three parts. The first part, accelerated part. In the accelerated part, the initial speed is 0, the acceleration is 2 meters per second square, and the time is 10 seconds. Therefore, from this, displacement 1 is equal to v naught times t plus 1 over 2 times at square. Since v naught is 0, this goes to 0. This is equal to 1 over 2 times acceleration is 2 meters per second square times time is 10 seconds. 10 second square. This is equal to 2 goes with 2. 10 square is 100. 100 second square with second square. 100 meter is left. For the second part, constant motion part. For this part, the speed is constant. B is equal to constant. That is, B at t is equal to 10 seconds is equal to B at t is equal to 15 seconds, which is equal to 20 meters per second. That we are already found. Therefore, displacement delta S2 is equal to simply B times T. The time interval between 10 and 15 seconds is 5. This is equal to 20 meters per second times the time axis is 5 seconds. 5 second goes with second. 5 times 20, 100 meters. Because our time in this case is t is equal to 5 seconds. Therefore, distance 2 is equal to 100 meters. For the decelerated part, third part, decelerated part. V naught is V at t is equal to 15 seconds. B at t is equal to 15 seconds is 20 meters per second. The acceleration is minus 3 meters per second square, and the time is 5 seconds in the last 5 seconds. Therefore, displacement 3 is equal to v naught times t plus 1 over 2 at square from equations of motion. This is equal to v naught is 20 meters per second times time is 5 seconds plus 1 over 2 times acceleration is minus 3 meters per second square times time is 5 seconds square. This second goes with second. 5 times 20, 100 meter minus 3 over 2 times 5 square is 25. Second square times second square is goes with second square, 25 meter. This is equal to 100 meter minus 75 over 2 meter is equal to 100 meter minus 37.5 meter is equal to 62.5 meter. This is distance 3. Therefore, total distance delta S is equal to displacement 1 plus distance 2 plus distance 3. Distance 1 is 100 meter, distance 2 is 100 meter. 100 meter plus 100 meter plus distance 3 is 62.5 meter. This is equal to 262.5 meter. This is the total distance traveled in the first 20 seconds. Therefore, this is all about this exercise. And next time, I will come with another topic and another problems. And thank you for your time.